Hello and welcome to my student. Today's lectures we have seen the various methods are used for the preparation of alcohols. Preparation of alcohols. The last lectures we have completed the other methods like the hydration of alkenes and hydroboration, oxidation of alkenes, hydrolysis of alkyl halides, and the catalytic reduction of aldehyde in ketones. Now we have see our here to prepare the alcohols by using the hydrides, one of the hydrides like sodium borohydride. Sodium borohydride. The molecular formula of this sodium borohydride like this NaBH4. Those reagents which are very selectively used for the reduction of only aldehyde and ketones. It does not reduce the carbon-carbon double bond, triple bond, as well as the other cyanide, nitro, such a groups which does not reduce the sodium borohydride because it is a weak reducing agent as compared to lithium aluminum hydride, and therefore sodium borohydride are more selectively used for the reduction of only aldehyde and ketones. Now we have seen our here two general reactions for this aldehyde like this. This is aldehydes. We can reduce by using this sodium borohydride, and then after reduction of this aldehydes to get corresponding alcohols are like primary alcohols, right? We have used this ketone like in presence of the sodium borohydride, then in presence of ketone to get the product is secondary alcohol, like RCHOH R-. So these two general reactions which are very important to understand, like the aldehyde gives primary alcohol and ketone gives secondary alcohols by using the reagent as sodium borohydride. Now we have seen are here the examples of some reactions. First reactions like this. Sodium borohydride. Then this sodium borohydride are reduced this carbonyl group to corresponding alcohols like CH3CH2OH. Similarly, other example we have Cr here. This is propanol. So this propanol we can treat with sodium borohydride. Then what happens? This carbonyl group can be reduced to corresponding alcohols like propanol. Other examples we have CRS. Such a type of aldehydes long chain of aldehydes we are used like the sodium borohydride can treat. Then this sodium borohydride it can reduce only the carbonyl group to corresponding alcohol. So product is CS3, CH2, CH2OH. So this is the product. Now we have seen here some of the other functional group which is present in these structures. Then last time what happens, if this CS3 we can replace by cyanide group, and those cyanide group which does not reduce by the sodium borohydride, because it is a less or it is a weak reducing agents. Similarly, other group we have taken like here, like nitro group, also the sodium borohydride which will not affect on this nitro group, means it does not reduce the nitro group. Nitro group here it is only reduce the carbonyl group. But in place of sodium borohydride, we are used as the lithium aluminum hydride. That's time what happens, both functional group can reduce. Nitro is reduced to corresponding amine and carbonyl group is reduced to corresponding alcohols. And therefore, sodium borohydride is the weak reducing agent as compared to lithium aluminum hydride. Hence, sodium borohydride is selectively used only the reduction of aldehyde and ketones only. Now we have seen other examples. We have taken another example like this. Sodium borohydride also, it does not reduce the carbon-carbon double bonds or carbon-carbon triple bond. So these examples we have used the sodium borohydride, and then this sodium borohydride which will not affect on carbon-carbon double bonds. It reduces only the aldehyde group corresponding alcohols, as like the product is CH3, CH double bond, CH2OH, right? Similarly, we have take other examples like by using sodium borohydride, it reduces only this group aldehyde to corresponding alcohol which is not reduced nitro group. So product is right. Next examples we have CR here. By using the sodium borohydride, then it reduces only this aldehyde group, the corresponding alcohols. Like CH2, CH2 and then OH. So these some of examples we have seen are here. The aldehyde group present in the compounds that convert into alcohols by using sodium borohydride. Now we have seen this How will you prepare the secondary alcohols? Secondary alcohols are prepared by using these ketonic compounds like these ketones we have take in presence of the sodium borohydride. This sodium borohydride can reduce only carbonyl group. So R, C, H, OH and then R dash. Right, this is the general reactions for the convert ketone to secondary alcohols. Now we have take examples like this acetone in presence of sodium borohydride. Then what happens? This sodium borohydride can reduce only the carbonyl group corresponding alcohol like CH3, CH, OH and CH3. Second examples we have Cr here. Sodium borohydride. What it is? The product? The product is that it reduces only the ketonic group. Right? This is the product. Next examples like so such a type of ketones like acetophenone. This acetophenone can treat with sodium borohydride. They use only the carbonyl group are here. OH and then CH3. Then next points we are going to discuss the preparation of alcohols using Grignard reagents. Grignard reagents. You know that Grignard reagents? Grignard reagents are alkyl magnesium halides, which is called as the Grignard reagents. Like RMgX, alkyl magnesium halide, is called as the Grignard reagents. And those Grignard reagents are used to prepare the various alcohols like primary, secondary and tertiary alcohols. Okay. So firstly we have seen general reactions like RMgX can treat with formaldehyde in dry ether because the Grignard reagents are decomposed in the water or the moisture. Therefore, such reactions they will carry out in dry condition only. They require dry ether. Then after hydrolysis with water to get corresponding alcohols. Firstly, we have C are here two general reactions. So this R is attack on this carbonyl carbon and to form the negative charge on the oxygen. So H, C, this H, R, this O minus Mg X to form the intermediate. Then this such a intermediates we can hydrolysis with water, acid hydrolysis to get corresponding alcohols like O minus pick up the proton from this and to convert OH. And byproduct is MgX, MgOH like H, R, H, OH plus MgX and MgOH. So this is a general reactions for the preparation of various alcohols using Grignard reagents. One thing which are very important to understand, by using the Grignard reagents in formaldehyde to get the product is primary alcohol. If these Grignard reagents are used in presence of ketone to give the product is tertiary alcohols, and if the Grignard reagents are used in presence of the aldehyde, then product is secondary alcohol. Okay, so RMgX RMgX plus aldehyde like acetaldehyde, dry ether. So what will the intermediates? This one of the hydrogen which is replaced by R, right? So R ONG X, this R, right? And then after hydrolysis with water, what happens? This O minus pick up the protons from this water and to get the product with alcohols like this R dash OH plus MgX MgOH to get the secondary alcohol. It is the primary alcohol, secondary alcohols. And next part, we are prepared the tertiary alcohols using the ketones like RMgX plus we can treat with ketones like these ketones in dry ether. Then what type of intermediate is there? This second hydrogens we can replace by R dash, right? So this R double dash OMgX R dash and this R. Then after hydrolysis with water, acid hydrolysis, then next time what happens? This O minus can pick up the proton from this water and to get corresponding alcohols like this is R to get tertiary alcohols. From these three reactions we clearly observe that we are use the formaldehyde to get the product is primary alcohol. We are use acetaldehyde, then product is secondary alcohol, and we are use the ketone, the product is tertiary alcohol. Okay, so next points we have seen is some reactions to get how will you prepare the alcohols like methyl magnesium bromide in presence of acetaldehyde in dry ether, right? And H2O hydrolysis. So what type of products are these? Is CS3, COOH, this H and CS3 to get secondary alcohol. Similarly, this methyl magnesium bromide we can add in formaldehyde to get the product by using same reagents, dry ether, acid hydrolysis, and to what the product is primary formaldehyde. So this formaldehyde, this CH3OH, right, plus MgBr then OH. It is a byproduct. Next reactions, we prepare the tertiary alcohols like methyl, magnesium, bromide plus ketone like a dimethyl ketone. So triether H2O acid hydrolysis. This CH3 which attack on this carbonyl carbon and to get the negative charge on oxygen. So this CH3O minus convert to OH by pick up the protons from water. So to get tertiary alcohol, right? So for these reactions, we conclude that we can prepare primary, secondary and tertiary alcohols using various types of carbonyl compounds. We are used formaldehyde to get the primary alcohol, we are used acetaldehyde to get the secondary alcohol, and we are used the ketone to get the product is tertiary alcohol. Right? The next points, we have seen the physical properties of alcohols. Physical properties of alcohols. So first property we have CRAS, dipole-dipole interactions. Dipole-dipole interactions, or another name is the hydrogen bonding. Hydrogen bonding. You know that hydrogen bondings are the dipole-dipole interactions or in electrostatic force of attraction between the two oppositely charged ions, which is also called as the hydrogen bondings. Hydrogen bondings is another name is the dipole-dipole attraction. Hydrogen bondings are the attractive force which is occur in any compounds which present the OH and NH. OH and NH. So such a type of group which is present in the molecules, they shows the hydrogen bondings, like the water, alcohols, amides, amines, carboxylic acid. So such examples which is shows to present the hydrogen bondings. But you know that in OH, oxygen is more electronegative than hydrogens, and therefore it chances the electrons can pull from this hydrogen towards oxygen, and hence oxygen carries partial negative charge and oxygen carries delta negative charge and hydrogen carries delta positive charge. Similarly, these amines also, the nitrogen which are more electronegative than hydrogens, and therefore nitrogen carries delta negative charge and hydrogen carries delta positive charge, and therefore hydrogen bonds, it is a weak electrostatics bond formed between positively charged hydrogen atom with another electronegative atom in the same or different molecules. Hydrogen bondings are of two types. First one is a intermolecular hydrogen bonding. Intermolecular hydrogen bonding. And second is a intramolecular hydrogen bonding. Right? Now we have seen in alcohols to present intermolecular hydrogen bonding as like so such types of intermolecular hydrogen bonding which is present in alcohol. Intermolecular hydrogen bonding which is present in alcohols. And intramolecular hydrogen bonding which is present like the salicylic or orthonitrophenol. Firstly, what do you mean by intermolecular hydrogen bonding? This is a intermolecular hydrogen bonding means the bonding present two different molecules is called as intermolecular hydrogen bonding. Which is two different molecules? This is the one of the molecules, this is second molecules, this is third molecules, fourth molecules, or so on. So number of molecules which can join with positive and negative OH. So this type of hydrogen bonding which is called as the intermolecular hydrogen bonding means one of the man and other mans we can join the hands with each other. This is called as the intermolecular hydrogen bonding. Intramolecular hydrogen bonding means the bonding we present within the molecules is called as the intramolecular hydrogen bonding. For example, this is one of the molecules and this is present the intramolecular hydrogen bonding like this. This is my hand and this is my hands which are joined with each other which is called as a intramolecular hydrogen bondings, right? So such a types of bonding which is present in orthonitrophenol. We are seeing here like this O minus H, right? And this hydrogen bonding which is present within molecules, right? This is a one molecules and the hydrogen bonding which is present intramoleculars, like these oxygens and these hydrogens, right? This oxygen and these hydrogens which are joined with each other, this is called as an intramolecular hydrogen bonding. So this is a intramolecular hydrogen bonding, right? Similarly, other examples like salicylic. So this is a salicylic. The salicylic also present intramolecular hydrogen bondings, right? And therefore, this type of hydrogen bondings which will affect on the physical properties of the molecules. So such types of bondings we can break can require is about 5 to 10 kilocalorie of the bond energy. So these are much less than the strength of the covalent bonds, and hence they are very significant effect on the physical properties of the alcohols. Okay, thank you.